Hello guys, welcome back to my channel. We are continuing with this layout. We started it a couple of months ago. We will continue designing the items. We shall finish. Be sure we will finish. It is taking more time, but we will finish. Right? We have dealt with most of the items here, and currently we are on the savory area. We did the bain-marie and the hot table. Now we are going to do a small item here known as a salamander. A salamander, the best of my knowledge, is similar to a microwave, right? A microwave. I don't know, but I see it as a microwave. Therefore, let us see the design of the salamander. The size is, it should be 800 by 450, yeah, and the height should be 400, and it has a grill, a removable grill. It is electric. There is the eating element is on the top here, and it has panels made of galvanized steel which are insulated so that you may lose no heat, and the body, the outer body, is made of stainless steel, right? Yes, here is the salamander. This is the grill, which is removable. Yeah, this grill is removable, and it has three rails, can I call them chambers? Yeah, you can do it at different heights. Here we have the electrical control, and on this side, as you can see, this panel, this is bigger than this. Actually, this is 100, while the other one is about let me see, 40 millimeter, because here is where you will put your conductors. Your electrical stuff will be hidden here. This panel is removable. All the panels actually are removable. Yeah, you do bolt self-tapping bolts or bolts with inserts, so that you may access in case of repairs and all that. This also panel is removable, the one that is hiding the eating element, right? It's a guard that is hiding the eating element, and it's perforated to allow it to go to your food. I have learned that you normally place your food, the food that you want to warm, on the grill. The food is in a plate, you place it on the grill, and you do your warming, right? So without much ado, let us get right into designing a salamander. And we are going to start with the bottom. We go to new part, click OK, then it go to top plane, a new sketch, center rectangle from the origin, and the size is 800 by 400. Click OK, and you go to sheet metal, base flange, and the base flange, the thickness of this can be 1.5 or 1.2 depending on what you have. These other factors you keep, you don't change the K factor and all that. The outer relief, make sure it is on tier. Click OK. Then you do edge flange, the whole sides, and the edge flange for the bottom one should be 50 millimeter, and condition blind 50 mil. Click OK, right click, then you do edge flange again, and this should be 15 mil. And condition blind 15 millimeter. Click OK. Remember, you can change the millimeter, the units that you're using from here. You can use meters, kilograms, seconds, or centimeters, millimeters, inches, and all that. We are using metric system. The bottom is complete, and you can go ahead and save it in your new folder, in the folder that you've created, the way you normally save your things. And as for me, I have all the items here, and this I called Salamander, and I call it part number 1, Safari Salamander bottom. Click OK. Then you go to new part, and we are going to create the back. And the back, as you've seen, the ITs. We go to front plane. Start a new sketch there. Center rectangle. Again from the origin. And this is 800, and the height of the salamander will be about 450 there, because of that 50 millimeter that is down there. So the body should be 400 millimeter. That's okay. Go to sheet metal, base flange, same parameters. Thickness is 1.5, and everything else remains the same. Okay, now here you do an edge flange on this side and this other side, and this is end condition is blind. The size should be 30 millimeter. Right click, then edge flange again. From here, going towards the inside. This is to accommodate the cover panel, which will be hiding the insulated panels, and this is blind. Size is 25 millimeter. Right click, then edge flange again here, going towards the outside. This side also, and end condition 15 millimeter, blind. Right, now finally do an edge flange all around. Edge flange of 15 mil or 10 millimeter. Remember, with this edge flange you can do on the top and mirror it to the bottom, or you can do all of them. Right, you can do all of them, all of the edges. This gives your item strength and a neat finish. Nobody will raise any safety concern when you have edge flanges that are going to the inside. And when you're doing the assembly, it will always give you a very nice finish. Right, so that edge is, and condition is blind, and the edge size is 15 millimeter. Is it overlapping? Yeah, it is overlapping. From this side it is overlapping, so we can do 10 millimeter. 10 millimeter is ideal, and it's good. Right click, and your back panel is good. Yes, your back panel is good. Let us try to see the flat pattern. Flat pattern with all your notches that you want, and you know, it will be okay to save it from that point. And this is part number 2, SS back panel. Save. Now we are going to create this panel here, this panel that is going to the side where the electricals will be fitted. So we go to new sketch and go for part, okay, and again front plane sketch, and we're going to take center rectangle, the origin size is 400 again, that is the height, and this is 100 mil. Base flange again, that's nice. Then you do your edge flange, going to, sorry, I didn't expect to do that. What's going on with the top plane? This we don't need. I don't even know how it came up there. Is that the, yeah, that plane is okay. So we are doing edge flange, and we are not doing up a tab there. The size of this should be 50 mil. Right click, that's okay. And here is another edge flange of 20 millimeter, and condition blind 20 mil, that's okay. Edge flange again on this side, and that should be a blind size is 25 mil, 25 mil, 25 millimeter, that's okay. Then going to the inside again with 25. That's good. I feel like we can make this 30. This we edit and make it 30. But some of these are normally determined by your bending tool. You know, the idea is to make sure that when you're bending, the bending tool won't be touching this surface or this surface, thereby creating marks. That edge flange is 15 millimeter. Right click or click OK to exit the flange. Now you need to have edge flanges round of about 10 mil, and condition blind 10 mil. There, here, here, and here. Also this other side. Told you it's always important to have this edge flange. Don't leave it. Whether it will be covered or not, don't leave it, okay? Now you can choose the top plane, go to features and mirror, and what you're going to mirror is that last edge flange. Click OK, exit the flange. Flat pattern of the same should be like this. Yes, now you can save this part as a DXF for the purposes of feeding it to the CNC machine, and to have your piece cut as per the required size with all the notches and slots and everything. And this we said is SS side panel. You can say electrical side, you know, you just save it the way that you will distinguish it from the other side. Now we have we go to new again and make the part for the other side, right? Go again to front plane, new sketch. You create the base flange, center rectangle to create the base flange, and the size here is again 400 by 40 millimeter. 400 the length is 40 mil. Now I kind of find this a little bit click OK. This panel normally gives people all sorts of problems when you are doing the bending, right? If you have a guy who is not very good at bending, they will have issues. They will cry, but hey, this is 20, sorry, condition blind 20 millimeter. If your guy is good, they will know what bend to do first. This should be 30 mil. Click OK. Then going inside here at 20. This is what I'm saying. This is not always some piece of cake when you are doing the bending of this part. It's not some piece of cake. This is 15 mil. Be sure that you know, if you are not careful, you are not going to achieve this part while you are doing your bending, especially the guys who are doing the manual press. Do we call it press brake? I don't know, but that manual bending machine will give you trouble like nothing else. It is that campaign time in Kenya, so you will hear a lot of noise from the background. People are trying to get that vote, and in Kenya or in Africa, our campaigns are totally something else. Mirror. Okay, so, and I hope it won't get me some copyright. You know, I'm not interested in their music or in their campaigns. Oh, we have an issue somewhere, which I don't know is what. How come? Yeah, I get it. Let me delete this mirror, and we do it manually. We do the edge flanges. Sheet metal edge flange. Yeah. I didn't want to this at condition 10. You can even do 8 millimeter to avoid all issues. Well, should you have issues with this edge flange, with this part, right? I know the bending is not, it won't be easy. Should you have issues, you can make, instead of making this 40, you can make it 50 or 65, right? That is up to you. It's a small piece, and you find it giving you troubles, you know what to do. This is 3A SS panel, side panel. This is not the electrical side. Right click, that is okay. Now let me go ahead and do the insulation, the panel that will be insulated, that will be bearing the insulations, the side panel with insulations. We did take the side plane, and here we are doing it. The size should be is it 334, 335, And height of the others, we gave them what, 450, 400, 3. What is the height? 400. So this we can give it 395. We will see when we start doing the assembly. We will always edit 1 millimeter, and this panel should be made of GI. Okay, you know, stainless steel normally deforms very easily under heat. Yeah, so you do this, the inner part you use galvanized material. You can't use mild steel, because mild steel will require you to do some painting. That edge flange there is 20 millimeters blind, will require painting, and the paint will peel off, right? So let us make this material. We go to the old part, material, we choose material, we go for metal, and we go for GI, galvanized, and we go for plain galvanized. Double click, and that part will be good. And this we go and save. Go ahead and save this part as part number 4. SS, no, we call it GI Salamander, Savory Salamander, in side insulation. Side insulation. You know how to save them, you know. The saving, the name that you will call it, is not as important as to know what to do. I want to check the internal dimensions, because this to here normal distance is 333. Let me note it somewhere, 333 by, because you need another panel which will go inside of this, by 393. Okay, now we create new part, steel side, right plane, center rectangle. We have seen this should be 333. Let me put it 331 because of the bending allowance, by 391. Bending allowance will bring it to the actual size that you want, 1 millimeter steel. And the bends, the edge flanges will be opposite of the other part that we just made. Okay, and should be a little bit smaller, 10 mil, as opposed to the other one which is 20 mil. This should be 10 or 15. When 15 is good. Right click, go ahead and save it as part number 4A. 4A, insulation cover. Okay, now let me go ahead and start the assembly. And the first assembly, I'm going to make new assembly. Click OK, check your custom here, and instead of doing custom, let us first do insulation cover. Then we change from custom, we go to millimeters and grams is good. We insert again, and we go for the cover. There we go. By the way, this also should be galvanized. Okay, galvanized. Now, how are we going to mate it? We are going to mate this. This part should flush with this. Okay. Yes, like that, because in here is where you put your fiberglass. Then you can go for the planes. Is it the front plane? Yes, the front plane and the other plane and the other front plane. Yes, that's good. Then the top plane and the top plane of the other. That's good. Let's see. Yeah, you see, it's a double skin kind of thing. A double skin kind of panel with fiberglass in there, fiberglass insulation. Okay, it is recommended to have fiberglass insulation. Now this you can go ahead and call it what? Side insulated panel. Okay, now we can close it. This we make material galvanized. Okay, do we need to close it? Okay, yeah, we can close also this. Save all and close. Also this we can close. This we don't need to close. Now can we do the back part, the back insulation part? Front plane, new sketch, center rectangle from the origin. What is the size? The size, and I promised you we are going to edit them. 697. The height is 395. Did we do 395? 395. We'll always go back and edit where necessary. Sheet metal base flange parameters, you don't change anything, and do an edge flange round of 20 mil. 20 mil. This is 20 millimeter, and condition, right click, that's good. Then you choose for the part and assign material is also galvanized. Now we need to evaluate and go measure so that we may know the cover. What is the size of the cover? That is 695 by 393, I think. Yeah, it should be 393. From here to here, 393 by 393. Okay, remember we didn't save this. We can go ahead and save it. It's part number 5. GISS back insulation. Then we go to file, new part. Okay, and we go for front again, new sketch, center rectangle from the origin. It's always very good to know which plane to use and the origins to keep. 695 by 692. Do 692 here. 92. Always very good to know the planes because of assembly. 391. Yeah. See, many a times when you're doing your assembly, you will find yourself required to met some planes, and if the planes are not right, if you choose the wrong plane, to be required to do some rotation and when you are mating, the mates will give you so many troubles. So make sure you choose the right plane and the positioning of the origin and all that. This is 15 mil. Okay, I hope don't mind the talk. Material same, galvanized, and save it as part number 5A. 5A. And GI insulation cover, back panel insulation cover. Okay, now we do a sub assembly. Where new assembly, right? Click OK. Insert component. We need side insulation. I think I should have chosen both, but it's okay. Then insert again a cover, just like the other one. When you're mating, this face flashes with this. Then you go to the planes. Like I was saying, you will find that you are required to do plane mating, right plane and right plane. That's good. Then top plane and top plane. That's good. I hope that gap is a bit big. This gap is a little bit big, the side one. So let us edit this sketch and add 1 millimeter. I saw it coming. This should be 693. Good. We can close that. Yes. The assembly, the sub assembly. Yeah, now the gap is manageable. When you put your fiberglass in there, that is where you are going to do your tack weld. Just kidogo, just a small tack weld somewhere at the corners, all right, to make sure the panels don't do what they don't disassemble when you're doing the main assembly. Okay, now that is good. Let us go to the main assembly. And the first part we are going to insert is the bottom. That's good. Then we will go and bear with me, we put one part at a time. We can do the back panel. That's nice. Met. This side flashes with this. That's good. No. We shouldn't have done that. Please. Okay. Let me first delete this and make the cause this to float so that I may do some mating. And the matings we are going to do is this plane, the front and the front. That's good. There would have been no harm in continuing with the assembly as we had started, but it is always good, you know, for you not to be pulling down some menus here and there, trying to go for the right plane that you want, you know what I'm saying, then fix it. Yeah, that is better. So instead of you expanding that, if you choose this plane, it coincides with the plane, the front plane of the bottom part. Okay, now file, insert. Sorry, we insert component, and the component to insert, we can even go for the side electrical part. That's nice. Met it, and this side flashes with this. this with this, right click, and this sits on top of the bottom plate. You tack weld, you do some welding here and some welding here, and of course to the top. Did we make top? We didn't make top. We will design top. That is side panel, side, so the side with with no electrical met. This side flashes with this again, and this with this, and since they are of the same height, this can flash with this same height. Good, right? That's much better. Now let us insert, we browse and bring in the side insulation. Where have we project? Side insulated panel. Good. Oh yeah, open. Okay, yes, that's good. Now met, this flashes with this, okay, and this flashes with this. I think we gave the height, and we will see this sits on top of the bottom. Let me see. Yeah, there is a small clearance of about 5mm. That is good. Now we can't mirror. If we mirror this and follow this plane, let us see, it will not be in the right position because these lengths are different. Okay, see where it is coming? Yeah, and that is not where we want, right? So don't get tired. Just okay, two things. You can create a plane, a reference plane where you are going to mirror by, or you can insert again the whole side panel, side insulated panel. Where is it? Side insulated panel. And this time round you need to rotate it, right? Where there is the joint, you don't need it being visible from the inside. What do I mean by that? Yeah, where there is this joint, you need a clean face inside the salamander. Okay, met, and the first met is this flashes with this, right click, and this face flashes with this face, click. Are they flashing? Yeah, and this face flashes with this, good. Now insert again component, insert component, and this time we want the back insulated. Did we? Yeah, that is not what we are looking for. We want the back insulated, back insulation, back. Let us see the sub assembly of back insulation. Panel. I think we didn't save it. Did we? Yeah, we didn't save this. Where are you? This. No. This is what I'm talking about. In fact, let us save it as back insulation. Back insulated panel. Yes, that was the reason why we were trying to insert it and we couldn't see. Now I have realized we need to rotate it just like the other one so that we may have a clean finish inside. Right, that is good. Now matting, I'm not sure whether the height is good. Anyway, we are going to edit it, that one to that, right click, and this face should flash with this face. Yes, those panels we need to, the side insulation, we need to do some adjustment. We will see. Now can we go to advanced mate and do width, and we choose this, and this, then this and this. I want to see whether the size is correct. Yeah, the size is absolutely correct. Now if you can see, that back panel, that back insulation has gone out with what, a few millimeters, right? A few millimeters. So let us evaluate here and see what is this. From here, normal distance from here to here, the normal distance is 350, right? 350, and if you can remember, this is 50 millimeter, this is 50 millimeter, so we are left with 300, and this is 20, that should give us 280, right? And you need some little space between this panel and the other panel, so you can get 280, 275, right? So this panel, these side panels should be 275. Can we edit it from here? Yes, edit. Yeah, first we save, and we shall call it Salamander. Why did they call this equipment Salamander? I've never known. Now we are in the edit mode and we are editing side insulation, which is this. We go to base flange, that sketch 335, so we are talking about 290, is it 275, 275. Just one second, 330. I want to know the difference so that when I'm editing the other, I will just input the difference. I will subtract the difference. 335 minus 275, 60. So we need to reduce this by 60 millimeter. Minus 60. Yes. I don't know. No, this is, yeah, I felt like it was big. The back panel here, the size that we are giving it here is big. So let me see, just hold on a second, guys. 275. We said this was what, 400 minus 50, 400 minus 70, it is 330 minus 325. Can we do it? 325, 325. we see. Just hold on, please, guys. Hold on, we see. Yeah, this is good. Now we have only one particular problem. I don't know how much to... Which one did I edit? Surely. Yes, this, I need to edit this also. This part, edit. What happened? What am I doing? Yes, edit. I'm telling you, the other one we have done 325 minus 3mm, 322, 323 minus 2mm. Yes. Save. Let me go for the Salamander. Subassembly. Is it right? Yes, it is right. It is good. Yeah, so you see the body is taking shape. Now we can insert our back panel. Insert back panel. Insert back panel. Back. We are looking for back. Not insulated, but back. Yes, back panel is here. Back panel. Now we do the mating, and the first mate we are going to do is to make sure that mate this flashes with this. That's good. And this sits on top of the bottom panel. Then we go for the, is it right plane? Right plane, and the right plane of the whole thing. Yes, that's good. Sure, that is pretty much good. Now, here's the thing. On this side, because remember your element will be somewhere up here, you need to drill some holes for the wires, for the electrical cables to go to the eating element, right? So you know what to do there. Now we also need a top insulation. I think we hurried very much while we were doing the parts. This to this edge. Let me get the normal distance from there to here. Normal distance is 325 by from here to here. Normal distance is 660. Okay, so let us do the top insulation. Go to file, new part. Okay, top plane. Okay, center rectangle, and this we have said is 660, 650, 660, 658 if you want, by 325 minus 2, 323. Sheet metal, we go to base flange, 1mm also. This is also G high, do edge flange going on the upward direction, also 20mm. This is 20mm. Material still G high. I know you're wondering why we didn't do material for the outer part, the stainless steel part. Well, We won't go into rendering, we will do it later. GISS top insulation panel if you want. Then we go to 1 second please. Let us close these that we don't need. Okay, most of these we have done with them. We have even done the assembly. We don't need them for now. They can wait for us. Should we need them, we will recall them. So file, new part. Okay, top again, center rectangle. This time around make it a little bit smaller with 2mm, 656 by 321. Shade metal, base flange, same parameters, and edge flange going on the opposite side of the other one that we have just made, and that is 15mm size material. Now you know, save it as that was part number 6A, and add some cover here at the end. Now we can go to file and do some assembly, sub-assembly of the top insulated panel, and we need the insulation, then the panel, the cover. That's great. Now we met, and this as usual flashes with this edge there. Then for the planes, the right plane and the right plane. Which plane and which plane? No, this, clear this, delete that right plane and that right plane, front plane and front plane, and that mat is good. Yeah, that mat is good, the clearance is good, perfect. Go ahead and save it. Save the sub assembly as top insulated panel. That's good. Taking some bit of time. We go to the main assembly of the Salamander and insert component. What are we mating? We want to mate something and we have not inserted. Yes, there. And this we mate. This flashes with this, right? And we can go for width. Advanced mate. We'll do the width thing with this and this side, in between this side and this side, right? That's good. Then we go back to standard mate and go for coincident. And this face should touch the back insulated panel. Yeah, our Salamander is taking good shape, right? Yes, actually it's just like a box. Now we need to make the top panel, the stainless steel top panel. So before we go there, let us close this, and we close this, I never like to have so many opened things, and probably you don't need them. New, we go to part, new sketch, top plane, new sketch, center rectangle. Now the bottom was what, 800 by 400, so we are going to add 15 mil. Is it so? Yeah, 15 mil, 15 on both sides, so it will be 430 by 800, 830, 830. Is it so? It should be the other way around. This should be 430. Sorry for that. And this should be 830. Yes, like that. Sheet metal, base flange, you change the thickness to 1.5 mil. 1.5 millimeter. That's good. Then edge flanges. The top, you can make an edge flange of 40 mil. Remember the bottom one is 50. You want some symmetry, make it blind, make this 30. That will look small. 30 is good. And remember, the edge flange down here should be 15 mil. That is why we were adding that 15 mil, 30 millimeter 15 on all sides. You know, assumption is a bad thing. Somebody might assume you know why we added the 30 millimeter, but once we are done with the assembly of the top, you will see why we did 15. We added to the total size of the bottom, we added 15 millimeter, right? Now, instead of you doing all this and drawing this part, you can save the bottom part as, and you call it top, then you edit the sketch. Feel me? Though it will have a lot of editing. This is SS top panel. Yeah. Let us go to the main assembly and insert the top. Insert top, and this top, now we made the bottom side, the inside of the top should flash. You know, this top we should be touching a layer. Now I feel like the planes should be good. Let us collapse this. We can go for the bottom panel. Yeah, the top panel. Where is the top panel? Top panel, front, and this front. If that is good, then a right and the right of the, which one is this now? Are they good? Yes, the mate is good. Wonderful. Now see, the top is protruding with 15 millimeter on this side and 15 millimeter on the other side. That is why we did what we did to the sketch. Yeah, and collapse this. We collapse it to avoid confusion. Can you see this? Can you see the protruding 15 millimeter here? Now also this panel here, you will punch a hole for the what? For the control, the electrical control. See the electrical controls? It's the zoom button here. That is trial and error, my friends. I can't see the zoom. The plus button. Yeah, you need to punch an hole for this, but that you will do depending with the size of the knob that you're going to use, right? So that is done. we need now to do the side covers, and the side covers, they should be having some rovers, right? Now we can we need to evaluate and know the size of the side covers. That is from here to here. That is 340. 340. What is the height? The height should be from here to here. That is 371. You can even do 368, yeah. So we go for we go ahead and open file, new sketch. Which plane are we going to use? The right plane. New sketch, center rectangle. What is the size of the height? We have said the height should be 368. The length should be 340 minus 2, 338. You need some allowance, right? And I even feel like 338 is small. It's big. 336, 336. You know, after bending, you will get your 340 or 338 there. Base flange. This you can do 1 millimeter, and it is stainless steel. 1 millimeter. It's not bearing any weight the way. Now can we go ahead? We don't need a sketch there. Oh, we need the side part. Now we go to design library and try to get some rovers in millimeters. What we are looking for, is it standard punch? No, I don't think it's standard punch. We need standard form, and what we're looking for is a rover. Yes, the rover. And this rover, we need it here. Now we can go and choose one. Do we need to custom size it? What have they given us as the value? The length is 20, the width is 7, I feel like this is good. One thing, okay. Let us try to edit. What are we supposed to edit here? This the placement sketch. Yes, the placement sketch. This, no, sorry, this to this, you can leave it at, is it 30 or 50? 50. And this to this, you leave also 50. Yes, that's good. Now we can go and do some linear component in this direction. That is the first direction. The opposite, look at the arrow size. We need how many? Can we try 5 and we do 100? And what we are going to do, the component we want to linear pattern, is that 100 is way too big. I'm wondering why. 50? No, even 50 is a little bit big. You can do 30 and 40. The components, don't know what is this distance. I'm tempted to do what? To make this small. Let me go for the second direction and see. No, not that face, clear. This edge. And I don't need, I only need like what? Like three rolls. No, 3 is little. 5 rolls. Yeah, that is good. But I feel like, should I add one? No, I reduce this to 30. Yeah. Let me first exit that. Is it possible to evaluate, not direct editing, but evaluate from there to there? Normal distance is 27. 27 plus 50, 77 divided by 2 should be what? 77 divided by 2 is around 38.5. So if I go for the placement sketch and I edit this to 38.5, 38.5, we see whether we are going to get equal distances. Yes, this looks very much symmetric. Now that is good. Now we need to go to sheet metal and add some base flanges. Remember your rovers are on the other side. See how they are going? So we'll rotate this, okay? And this should be 25. We can do 24 because we need it flashing with 24. You know how it goes. I'm sure you've been following these things that we have been doing. So some edge flanges, some of these panels you can even predict where they are coming. In fact, you even saw where we evaluated to get the size of this panel. So that bend there was 25. That is why we did this 24. You don't want to have any issues when you are mating it. And you realize that the panel is not flashing, it's protruding on the outside. Yeah, we are going there. Let us just save it as part number 8, part number 8, and we call this SS side removable. Cover. Side removable cover. Good. Now we go back to our assembly. We don't need top. You can close your top. Assembly, and we insert component. That component we are inserting is that removable cover. Yes, this we don't need to rotate. We'll rotate for the other side. Now I'm saying this bend here, you remember this bend here was 25 millimeter. That is why we did 24 to give it an allowance. Yeah, we don't want to have it to be super tight or it doesn't flash well. Okay, that is the idea. This face should sit on top of the bottom. Then we can go for, let me pull all this side and go for advancement, and we go for width. This should be in between the back panel, the back stainless steel panel, that is between that face, and the front, this face here. I hope our measurement was good. Let's see whether there is a huge gap or the edges are overlapping. That gap is a bit big, so we need to edit this. We edit this and we will go to edit the sketch, the base flange sketch, and add 1 millimeter to it. Is it 1 or 2? 338. We make it 338. 338. Yes. See whether the gap will reduce. You don't want it to be tight, and you don't want it to leave you with a very big gap. Where are we? No, it should be the other side. Yes, that gap is manageable. Okay. Well, why do we need a roofer there? Beats me. Okay, you can find out. But you know, because this thing doesn't have a door and the heat should not be, you know, you are not confining a lot of heat here. Why do we need roofers? You guys, we have been importing these things from you. Why have you been putting roofers there? Well, one of the reasons that I can give, as far as I'm concerned, is beauty. But what I know, we don't need it. Probably probably what? For a gas operated, gas run Salamander, you for sure need some roofers for aeration, yeah, to keep the flame going. Which one is this now? Right, we need this. We are doing width mat, fellas. Why are we not getting? What's going on here? We are going for advanced. We didn't choose what kind of mat we wanted. For a gas operated one, you might need the roof. You need to give aeration space. But for the electrical one, put it some roofers here. I don't get it. Yes, we need to create the runners, the rails, yeah, the rails for the grill. Okay. We need to get this size. What is this size? Let me open this component and see what is the base size of this. It is 325, so we can do 323. We discard. We were not going to edit that. We were just going for the size. Can even close it if you want, though there is nothing we have done there. Go to file, new part. Okay. Front. Is it front or right? Right sketch. Center rectangle. Not corner. I hardly use corner rectangle. I'm choosing it again. I need center rectangle. What's going on? And the height should be 30 mil. Grill. We'll design grill. Don't worry. 323. Not surface, but sheet metal. We go for base flange. This can be any size, but do 1.5 for the purposes of the weight of the plate with the food that we are trying to warm. Don't do big. This is 15 mil. Good. Now fillet for the purposes of safety. You avoid sharp edges, kabisa. You avoid sharp edges completely. What is kabisa? I'm using my local language. Kiswahili. My daughter calls it Kisauli. Okay, she's grown now. She knows it's Kiswahili or Swahili. But when she was around 3 years there, she used to call it Kisahuli. Kisahuli. Save this S. Part number 9. And call it SS rail. Grill rail if you want. So we go back to our assembly and insert component. Rail is the part that we are going to insert, and this will be welded. We are not inserting but mating. This will be welded on the GI insulated panel. Now when you're doing the assembly, I know you know what part you're supposed to start with. This face, this should touch the back panel. The back panel there. And now we need some distance here of about is it 50 or what? 50 or 65? We will edit that if need be. Between this and the bottom, 50 is good. Click OK. We need 3 of them, so we will linear component. Let us insert another rail. I don't want to mirror. That will give me some issues with looking for the right plane to mirror it about. Met just like the other one. This face welded to the side panel, right to the side insulated panel, and these flashes with the other one. I decided to right click, and this face I decided to put both so that I may linear both. Okay, I may linear component both. Okay, that's good. I don't know why we did 30 here. Looks big to me. We might change that size to 20 or even 15 because we are going to use a rod of 8mm diameter, or even you can use 10. Yeah, so linear component, and we are going to linear it against this edge direction, opposite direction. The arrow should go upwards. 53 instances, and the components to linear is this. 50 is small, maybe 100. 100. Yes, that's good. That will depend with the size of the can we edit it from here of the plate? You know, your chef will help you with this. We edit this sketch, and this we can make it 15 also. I'm sure your bending tool will achieve that. Exit the sketch and exit also the edit component thing. Yeah, that looks reasonable. The other one was way too big. Now let us evaluate. So because we want to create the grill, measure from here to here. Normal distance is 657. We'll give it an allowance, and from that back panel to the front should be 375, and it should protrude with something like 60 millimeter or 70, you know, because the grill should not have an handle. You will see the design, you know, it's a design. You can do whatever design you want. Sketch. Now we will go for the corner rectangle. The corner rectangle, we do this. We have seen the size to be this, to be 657, 654. Let us give it 3 millimeter allowance by 375 plus 75. 375 plus, let us do 60. Yeah, that is good. And since we are going to use a rod of 8 millimeter, let us fillet this by 4. We fillet all the corners, all the 4 corners by 4 millimeter. That's good. Now we take, the fillet is good. We take this point and the origin and make them coincident. Good. Exit that sketch. Reason for doing that, you will find out very soon. Now go for the front plane. New sketch and do the sweeping profile. Is it the sweeping profile or the sweeping what? And this is 8 millimeter. The rod is 8 millimeter. Exit the sketch also. Then choose sweep, 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 sweep. Yeah, sketch 2 is the profile, and the circular profile is sketch number 1. That is good. The grill is coming. Now with that, let us save it as part number 10. And we call it SS grill. Some people might want to call it mesh, others might want to call it grill. Let us create a reference geometry, and that is plane, and we should offset it by 60. Remember the other one, 60 minus plus 4. Is it 60 plus 4? Yeah, 64. 64. Flip side. It needs to go to the inside. That's good. Now we also need another plane, right plane. At this plane we need also to reference a reference plane here, and we offset it by, how many are we going to need? We can do what? This we are going to do 3. We will edit it. Let me give it 100. We will edit. No, 200. Yes, that's better. Leave it at that. Leave that at that. Save. Now go for another part, and this time round go for the right plane, no, front plane. Is it the front plane or the right plane? No, we need right plane. Sketch from the origin, and we go for a rod of 8 millimeter. Extrude it. Don't extrude it from the mid plane, and this should be 654 minus 8. This should be what? 6. Let me check. 654 minus 8. should be 646. Here 648, 646. We'll always edit. Save it as part number 11, not 11 but 10A, 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 grill, long part, long road. I told you, don't worry about the naming. As long as you know what you're doing, you can call it whatever name you want. I want us to do a sub-assembly of the grill. New assembly, click OK. We need grill. Then we insert again, insert grill long. Now let us met. Here we need this. Let us expand this and expand this. We go for the top plane of that and top plane of this. That's good. There is a plane that we chose here, not that plane. Is it that plane? Plane 1. Why we don't have that plane? Yeah, that plane is good. And the right plane? Yes, that is good. Then we go for the right plane and the right plane, right plane, right plane. Is that good? That is good. We need to edit this and make it a little bit longer. This we edit, sketch, save. We call it grill sub assembly, grill sub assembly. This part that we are editing, grill, extrude board. We can add like 5mm. Yes, that's good. Okay, this is for the purposes of designing, so you know what to do. In fact, we should add more, like 3mm plus 3mm. When you are cutting this, you know you should measure from here to here and do the notching, right? Yeah, so this is something that you need to be very careful. Don't follow the sketch of this. Don't follow this sketch when you are fabricating your grill. You know, you are supposed to follow the component that you have already assembled. You don't want to make a grill that is big or that is small, or you have cut sizes that are you need to recut again. Hey, be very careful. We need to linear component, and what is the direction? Let us go for, can we show the centers? The axis, view axis. Yes, make it visible because we need to choose this axis as our direction, and we need 4 of them. 4. What is the component to linear? That 100 looks big. We can do 65, oh no, 60 mil. 60, let us add more, 1, to, yeah, but the back one looks a little bit big. Can we make it 65 or 55? 55. Yeah, it's not coming. 63. Looks a bit symmetrical. Like I'm saying, you need to know, these are things that you are going to measure when you are doing the assembly, the fabrication, right? This is just for the purposes of illustrating how the grill will look like. Now we need the rods that are going in this direction. Now, what will be the size of this from here? I don't know whether have I ever measured a rod. The normal distance is 376. 376. Yes, and we need 2 of those. Might be, I don't know. Let's see. New part. Okay. This time round we are going for the front plane. Do our sketch from this. That's good. And dimension is 8mm. 8mm. We extrude it. Extrude in the other direction, and we extrude it by what's going on? Direction 375. 375. We are good. We save this as part number 10B. 10B. Long, short. Go to the sub-assembly of the grill and insert component. That one that we have just finished designing is what we are going to insert, and we mate it. How are we going to mate it? We are going to mate it with plane number 2, and let us get there. Yes, that one. That is good. I don't know. Is it possible to do a tangent? This tangent, this to this bottom. Yes, very much possible. Now, I don't know whether it will give us width, because we need front plane, that plane to this plane, to which plane? To plane number 2. There is something here. Grill. Plane number 1. Yes. That is very good. Now the thing is, that tangent is not good, because this should be lying under here, and you need, when you're doing the welding, you need to tack weld there. So what I'm doing is I'm just giving you an idea. I want to subtract 5mm so that it may stop protruding from the other side. I don't know whether it is good still. Save. Let me close this. I don't need this. I don't need this. Yes, I don't need this either. I don't need this. Yes, I don't need this either. If there is anything, we'll still need to edit it. Subtract like 3 mil. Extrude boss. Edit. Minus 3 mil. Did I do is equals or it is sub 367? 367. Looks good. Looks good. It looks good. Now, this we offset it by 150. I don't want to mirror. Let me linear component, and I'm supposed to linear it in that direction. We need 2 of them. I don't know whether it's 150 or what. 150. Yeah, some of these things I'm telling you, just give your guy your the materials and he will give you your grill. Shouldn't be 150. 300. 300. Okay, let me keep it like that, and we try to evaluate and get the distance from here to here. Normal distance is 150, and normal distance from this to this is 150 also. 200. There is a difference of 50 mil. Allow me to leave it as it is. Okay, allow me to leave that grill as it is. Save. Yes. When you are doing the assembly of the fabrication of this, get it right. Okay, you know how a grill is supposed to look like. The outer one is good, this other one is good. Just to ensure that the spacing is alright. Make sure that there is around 60-75 mil. This will go outside the, let me see, what other view do we have? See, it is protruding. Here we gave it 50 millimeter. Make sure that it is protruding and the others, get them right, please. Okay, insert component, and we have to insert the grill. Grill is there. How are we supposed to met? Let us go to met, and here we need to, can we collapse most of what we don't need? The rail 1, and go for the top. It's okay. No, I didn't want to take that. Let me go for the grill sub. Expand the grill sub. Then I go for this and go for the top plane. What is not happening here? What do you mean? What is not happening? Not tangent, but coincident. Top plane. Yes, that's good. That's better. Now, have you ever This, my friends, is trial and error. Okay, I'm just doing my trial and error. Can't work. Let me just exit that mat and go get myself some reference geometry and put the plane in between this. Right, I put a plane. I want to open this grill. Let me see, not front but right plane. I go to reference geometry plane. This was 657 divided by 2. 657 divided by 2. 328. So can I offset this by 328? 328. Yeah, looks like it is at the middle. Then I save. It is plane number 2. Wow. Yes. Now have I expanded this plane? I will mate it with plane, the top plane, yes, wanted it to be at that center. Okay, that's good. The only thing that I need to do now is to reduce plane number 1. Can I edit this? Is it possible to edit? Now I'll go back here. And this plane, where is that plane? Not that plane. Collapse this. Collapse also this and go for this plane and edit it. Here I can subtract around 5mm. All this I'm doing is trial and error, my friends. See whether the sub-assembly would work. I need to that's a lot. This is a lot. Can I evaluate? Evaluate measure that distance from there to this. No. Hold on a second. I want to get this distance from here. No. From that face to this. Normal distance. Is it normal distance? Around 32. So I will go and reduce that plane with 30mm. This plane, I will edit it and subtract minus 30mm. See whether it will come. What's going on? The distance is becoming bigger and bigger. In fact, I should do the opposite. Plane, edit. Should I plus 35? Plus 35. Oh, people. I'm trying to be lazy. Why am I getting this lazy? I should have calculated this thing very well and finish with it as soon as possible. But here I am doing a lot of trial and errors. 70. Yeah. This is not professional. I don't know why today I'm this lazy. Plus 70. Really unprofessional of me to do this. See? Okay, I will delete that net and forget about that plane. This net. Let me delete it. Yes. So what am I going to do? This is what I'm going to do. I will met and give it a distance of 2 millimeter. 2 mil or 1 mil. This to this. 2 millimeter. My grill is a little bit bigger. I will reduce that size kidogo. Yes, that's good. Good. Grill being big. Let us edit this grill edit. Collapsing what we don't need. As far as that edit is concerned, allow me to collapse the items that I feel like are not required to be expanded. Then I expand the grill. Then I will go for SS grill along. SS grill this. And I will go for the sweep and edit sketch number 1. Is it numero uno or sketch number 2? Yes, sketch 1, edit. And here I'm going to, let me see, yeah, minus 8 millimeter. This was made big by the diameter of the rod. Yes, that's good. Now, I shouldn't have exited the edit. Let me edit this component, edit. Extrude boss, edit, minus 8, minus 8 millimeter. Minus 8 millimeter. Great. Yeah, now our grill is sitting pretty. I will never do that again. I promise you guys, I will never do that. Now I don't want to add another mat because our grill should look like that. Something is not right. Oh, the grill is very much okay. Yes, that grill is okay. Our salamander is good, right? Now, what else do we need? Do we need we need a panel here for the legs. So Let me measure this from here. No, from there to this should be no. We should measure from this face to this face. And that is 370. File, new part. Okay, top plane, sketch. Length is 370. This you can do 100 or 75. Don't do a big bracket, big channel for the legs. Okay, base flange 1.5 millimeter is good. Edge flange here of what? That edge flange there should be around 50 millimeter, 48, and this, that's good. Do 15 mil going inside. 15. Yes, size is 15 mil. What's not happening here? 15. What am I doing? Edge flange. Go in this direction and this other one. Make this 15 millimeter. Save. Yes. Did we save and call it what? Save. It's so funny. What part number 19? I didn't. Okay, we'll leave it at that. 1 to 370. 370. Divided by 2. 3 to 5 minus 15. 170. So we go for front panel and go for reference geometry plane. 170. Yeah, that's good. Leave it at that. Now we go file a new and create the leg part. Okay, top, from the origin, millimeter. That's okay. Let us make this coincident at the origin. Exit the sketch. Go to top plane. Reference geometry plane. We need it to be 25 millimeter. Flip side. Click OK, then go for that plane and create a sketch. This should be around 20 mil. Size is 20 mil. 20-25 would be okay. Exit, hide this plane, then you loft this and this, not like that. Shouldn't be like that. Loft, why is it going like that? No, we are not sweeping, we are lofting. Something needs to be changed. This is better. It's not super perfect. I don't want to dwell very much on this. Yeah, I'm trying to do a sub-assembly of the leg in the channel. Sorry about that. This campaign guys, you know, I'm trying to avoid copyright. They are here making their noise. Now we go for the front and that plane 1. That's good. They are really disturbing us. Yes, front panel, front plane, and we mirror components, and component to mirror is that leg. Right click. That's good. That part is pretty much okay. Save it as leg and leg and channel sub. We don't need you. We don't need you. Save all. We insert. Yes, met. This should flash with this. Right click. This should flash with this. Right click. Then this. If you want, you can do with or, but ideally that should flash with this. So many options on how you can have your met working. Now, that being the case, we need collapse this and this. We need that right plane and to mirror components. The component to mirror here is that leg sub assembly. Yes, that one. Good. Now your Salamander guys is ready. Salamander is ready. Yeah. I am not going to show the control I told you because of where the whatever size of control you have, that is what you're going to input. Yeah, and that's it. Thanks so much for your time. Our videos are becoming long and long, taking a lot of time, but hey, you're learning something, and I'm also learning. Yeah, I'm also learning. And finally, I want to appreciate every one of you for all the support you have given me. My channel is still growing. I have not been very consistent. I'm still working on it. I will get to that point where I will be super consistent and give you content after content. You know, we have so much to cover as far as Solidworks is concerned, and also as far as commercial kitchen is concerned. We have so many items to design, not just what is in this layout, but we have so many items like the tilting boiling pan, the brat pan. We have so many things that you can't see here. We have items that are normally found on the coffee shop, and how to arrange your coffee shop, you know, how to arrange a bar, and the items that are found there, they were not captured in this layout. So there is a lot that is coming. Bear with me. I will work out a formula on how to consistently do a drawing every single day without getting tired. You have yourself a lovely day or night, depending on where you are and what time you will be watching this video.